All right, this is part 4 of material testing. What you see on the screen right now is you see 3 different test samples that were broken. And on the left side, what you're seeing is a test sample that was very ductile in nature. What you notice is this is half of the test sample, and as it was stretched, you can see that this neck was formed here, and it creates a kind of messy looking fracture plane. You'll notice that it has a lot of different deformation in it. There's a lot of different kind of three-dimensional shapes to it. As we move along here, the second one here is a something that is kind of in the middle between between brittle and ductile. You'll notice that again, it has a three-dimensional fracture plane, not really a very well-defined neck to it. And then the third one is a very brittle sample. So think of this as like some sort of clay type something, glass, something that's very brittle. And as this fractured, there was no neck that formed, and the plane that it fractured on is almost horizontal. So this is almost perpendicular to the axis in which it was pulled. So these are 3 different test samples, and you can see the wide variety of ways in which they can fracture. If we look at the stress strain curves of those two, this one is a good example of something that is rather ductile, something that has we'll say a moderately steep elastic region. But then we're looking at this plastic region, noticing that it has quite a bit longer distance, much wider spread here. So that is on the axis of strain. And you can see that it is able to generate quite a bit of change in distance, deformation, before it fractures here. Contrast that with something that's very brittle, has a very steep elastic region, so I'm applying a stress, I'm not getting a whole lot of strain out of it. And then as it starts to plastically deform, notice that this strain, the ultimate strain here, is really not that great, because as it starts to strain beyond the elastic limit, we only have this small little region here, and then it's going to break. So we could think of this as a rubbery type material, and this more as like a glass type material. Have much more deformation here, not very much deformation here. One more term that we can talk about is what's called toughness. So it says work per unit volume required to fracture material. Basically, think of this as how much work does it take to fracture this material, to break it. Something that is going to be very tough is going to be something that can flex quite a bit, but it still is relatively stiff. So we could think of this as some steels, some metals, some different types of plastics or rubbers. It's going to take quite a bit of work to pull it to the point that it actually does break. 2 more types of tests that we can talk about. One is called a compression test. And so notice that this is that same picture we saw before. These jaws right here are going to create a tension test. But if I were to put my test sample below this, I can create a compression test where this would come down and squish the test sample underneath there. Great example of something that would be compression tested would be concrete. You'll often see when they're building something, when they're building a highway overpass, when they're building a bridge, you might see that there's small little cylinders that are about 6 inches in diameter, maybe a foot tall. Those are all test samples for a compression test. And what they'll do is they'll collect those, and they are then going to compression test those to determine the strength of the concrete that was poured into that job. All of those come back to some place like this, and they need to make sure that they are meeting a certain requirement for the compressive test of that concrete. If it passes, all is well. If it fails, then they may have to make some changes with the actual design of the bridge. Maybe they have to rip out that part, maybe to re-pour it, maybe they have to add some more support to it. But regardless, they need to test each one of those pours from each one of those batches of concrete that come to that job. One more is a hardness test. So notice this is like testing the hardness of a material. What they're doing is they're actually pressing a ball at 500 pounds into a material, and then they're measuring how big the indention is on that material. There's going to be a standard, there's going to be a list of sizes, and that's going to allow you to rank the hardness of that material relative to others. And one more is this Rockwell test. Very similar. What they're doing is they're taking a cone that has a diamond tip on it and they're pushing it into the material, into the surface of the material, and then they're measuring how deep it does actually get into the material, and that's going to determine its hardness. So there you go. That is material testing on a whole. And if you do have any questions, please feel free to give me a holler. Thank you very much.